Okay, this is what I expect you to tell me. For example, I ask the student, which is myself, how to approach this. Okay, equation has real and distinct roots. Find the range of values of m. Therefore, I must find the discriminant and set the discriminant to be greater than 0. Do you understand what I'm saying? And do you understand why I say that?
Yes.
Okay, so by telling me that, I know that you are aware of how to do it. So to find the discriminant, I need to write down this equation in the form of ax squared plus bx plus c equals to 0. Then I can find my discriminant. Okay, so here we have mx squared plus 2m equals to 12x minus 3x squared. Change it into the form ax squared plus bx plus c equals to 0. So m plus 3x squared minus 12 x plus 2m equals to 0. Now I can write down my discriminant because this is on the form ax squared plus bx plus c equals to 0. You are supposed to be able to tag what is a, b, and c. So discriminant. Look at how I present. I write disc. I do not write b squared minus 4ac. Because the question, instead of using m, for example, what if they chose to put a over here? Then this is also a. Then by writing b squared minus 4ac, you will confuse me, you will confuse yourself. So never ever write b squared minus 4ac in your work. Just write discriminant. So discriminant, b squared in this case will be negative 12 square minus 4 times of m plus 3 and 2m. Discriminant. So based on this, it has real and distinct roots. It tells me that this must be greater than 0. Not equal to, must be greater than 0. Once we have this, you will get 1 mark. So we have 144 minus 2m times 4 minus 8m squared. Then we have another minus 8 times 3, 24m. Am I right? Okay. And this is supposed to be greater than 0. This one over here is quadratic, right? How do we solve a quadratic inequality?
Factorization.
Factorization, yes, we factorize. Here, do you want to have negative 8m squared or would you prefer to work with positive 8m squared?
Doesn't matter. Divide by negative.
Do you have a preference?
No. Doesn't matter.
Who prefers positive? Okay, mostly we'll prefer positive because for our questions, right, we always try to make them positive. But actually, it can be done with negative also. Let me show you how. For now, if I want to change it to positive, what should I do?
Divide by negative 8.
Divide by negative 8. Can 144 be divided by 8?
Yeah.
Okay, so we get m squared plus 3m minus 18. Okay, and this is greater than 0. Less than 0, yeah.
So we need to put 0. Need to put equal.
Where equal?
Like discriminant that equal below the 144.
Only this discriminant refers to this portion, and then I'm now saying that the discriminant is greater than 0, therefore this is greater than 0. So I don't need to keep writing discriminant equal already. Okay, from this step, let us factorize. What will we get? m 6 3 m squared 18 3m 6m. I require 3, so put a negative here and I get 3m. Yes, so this means that m plus 6 m minus 3 less than 0. Okay, after factorizing, then I feel like writing m plus 6 less than 0 or m minus 3 less than 0. Right or wrong? What could the student be thinking when he does this? This particular step over here.
Inequality remove.
What is the student thinking?
Separate the inequality.
Yeah. Why would the student think that?
Because when you want to solve inequalities, you have to separate.
No. Because usually when when we're not dealing with inequalities, we're dealing with equations, right? Suppose this is an equal sign, this is an equal sign. Then this will be equal over here, and this will be equal, isn't it? Right? You're all very familiar with this. But the moment I put in inequality, then you think that it can be done the same way. Then this will be wrong. Okay? The proper way to do it is by drawing a graph. What does the quadratic graph over here look like? Opening upwards or downwards? Upwards. What are the 2 points over here? -6 and 3. Okay, it will intersect at 2 points. So I want the region that is less than 0. So above or below the m-axis? Above or below the m-axis? Below lah. I want less than 0 ma, so it must be this region. Therefore, my range of answers will be m ranges from
-6 and 3.
-6 to 3. Okay, when we write down our solutions for inequalities, a range, it must always be facing this way. Okay, the arrow is pointing to the left. Never ever have it this way. Okay, because if you want to force it to be this way, then it will be a 3 over here and -6 over here, which doesn't gel with our smaller number on the left, bigger number on the right, isn't it? Okay, so we don't do it this way. So now, just for the fun of it, I will show you how we can do the same question from this step. From this step, without changing the sign for m squared. Okay, so same thing, I'll divide by 8 first. I will get 18 minus m squared minus 3m. And this is greater than 0, right? Okay, so now I want to factorize this also. I will get, what will I get? Will I get the same thing? So this is the factorizing, which brings me to m plus 6 negative m plus 3 greater than 0, right? Any problem so far? No. Okay, what does this parabola look like? Opening up or down? Down. Yeah, it opens downwards. What are the points of intersection? -6 and 3. What makes it go down? Because of the coefficient of m squared. It's negative. Okay, so now I want the range that is greater than 0. So above or below the m-axis? Above. Then I still get the same range, m between -6 and 3. Okay, so this is what it all means. I don't think I've shown this version to you before, because I didn't want to confuse you. You prefer for the coefficients to be all positive so that you always end up with parabola opening upwards. Fine, so be it. But mathematically, right, this one will still work for the same reasons lah. Can or not?
Yes.
Any questions so far?
No.
Okay. Next one, 38. Okay, let's start with Kevin. Since you're there. How do we approach this question? Expand, we get mx squared plus x plus mx plus m equals to 0. And then? Come on, we do have a lot of time. Discriminant, what is the discriminant over here? Huh? Can you write down the discriminant straight away? What must you do in order to find the discriminant? Okay, so we get mx squared plus
1. M plus 1.
M plus 1, x plus m equals to 0. Then what do we do? Okay, write down discriminant equals to, tell me what is the discriminant? Hey, discriminant. What's discriminant?
Zero. B square minus 4AC, yeah.
Class, in our quadratic formula, which part is the discriminant?
B square minus 4AC.
Does it ring a bell? Which one is B? Hey, ax squared plus bx plus c equals to 0. It always looks like this. So out of the ax squared plus bx plus c equals 0, which one? How do we get our discriminant? Just now they already said. B squared, okay, what's b squared over here? M plus 1 squared, then?
Minus 4.
Hey, you all are not Kevin, huh? And then?
C.
What can you tell me about the discriminant? What can you tell me about the discriminant? From the question. Why greater than 0? You need to revise, huh? Class, when we have real and equal roots, what does it tell us about discriminant?
Equals 0.
Equals 0, not greater than 0, Kevin.
Greater than 0 is.
So this is equal to 0. This is a quadratic equation. Go and solve. You get m equals to
Negative 8.
negative 1/3 or 1. Okay? Next, question 39. Cheng Zhou, it's not talking a lot, huh? How do we do this? Find the discriminant. What is your strategy?
This can be like same, right? It can be 0 or more than 0.
Okay, this is in the form ax squared plus bx plus c equals to 0. Then you want to find the discriminant so that? So find the discriminant first, right? Okay, so discriminant. X squared. X squared. 1 square. Okay, so are you telling me to evaluate this? Oh, just put down greater than or equal to 0, is it? Yes or no? What do you all think? Who disagrees with this? Okay, Darius, can you share your reasoning why you disagree? You need to find K first. No, they didn't ask you to find K. Ying Cheng, why do you disagree? The discriminant need to expand. So what's wrong with this statement? Is there anything wrong with it?
No.
Is there anything wrong with it, class? Yes, Sui Wen. What? When it's equal, then it's more than equal to 0. No, don't understand. Anybody else? Is there anything wrong with this statement? Presentation, I heard presentation. Zen, why do you say that? What's wrong with this presentation? No? Chen Zhuo, you want to change your answer? So you mean your first step will be discriminant greater than or equal to 0, is it? Also wrong. Darius, you want to try again? So is there anything wrong with this? No. Shift it to where? So you mean remove it now, is it? Okay. Now he says we remove it. This is now correct. What's the difference? Wait, so what's the issue over here? Why is it that when you put in greater than or equal to 0 is wrong, then you remove it is correct?
Is it direction?
No. Yes? And then? No. Okay, all of you listen. Listen carefully. The question says, show that it has real roots for all real values of x. Understand that, right? So eventually, I want to find my discriminant, and I want to show that it is greater than or equal to 0.
This assumption.
Understand?
Yes.
When I put the greater than or equal to 0 at my first line, I am already telling the marker, hey, my discriminant is greater than or equal to 0. Do I know that?
No.
Do you know that the discriminant is already greater than or equal to 0?
Not yet.
You don't know yet. That's why you are supposed to show it. Therefore, we cannot have this over here. It is just like our congruency and similarity. If the question says, show triangle ABC congruent to triangle XYZ. They ask you to show, then your first statement, answer. You say triangle ABC congruent to triangle XYZ. I don't care whether the subsequent right or wrong, you just get 0. Okay? They ask you to show it, you better not tell me that it is true at the first step. Do you understand? Anybody needs more clarification? Yeah, so moving on. So this is our discriminant. We get 1 square. Okay, let me just copy this down. This is 1 minus 6k plus 9k squared. So Chen Zhuo, you haven't finished it? This is our discriminant. Then what do we do? Factorize it, okay. We see that it is factorized into 3k minus 1 squared. Then what? Okay, at this point in time, is it clear that the discriminant is greater than or equal to 0 already?
Yeah.
Why is it so clear that it is greater than or equal to 0?
Because square.
Why is it so clear that it's greater than or equal to 0?
K equals 1
Because this is a perfect square. Right? This is a perfect square. This implies 3k minus 1 times 3k minus 1. Right? Which is our perfect square, 3k minus 1 squared. Now, if this part is positive, then this must be positive. So this must be positive. This one possibility, right? Oh, sorry, positive over here, right? This one positive, isn't it? Now, what happens if this is now negative? Then the other one will be negative, and this will still be positive. Is there any other cases I haven't tried yet?
No.
There is one more.
So when you say negative, right, do you mean...
Wait, hang on. The last case, if this is equal to 0, what is this?
0.
Then this must be
0.
0. So this can only have two possibilities. Either it is
Positive
or
zero.
greater than 0. Am I right?
Oh, sorry.
Is it ever possible for it to be negative? No, this is a perfect square. So at this step, you are supposed to be able to do all this in your mind. At this part, you should be able to conclude that it is greater than or equal to 0. This is where you put the inequality, not at the first step. So over here, we say shown. Okay? Because you have shown that the discriminant is greater than or equal to 0 already, so it is real roots. Can or not?
Yes.
Now, real roots, there are two other cases. Either both are equal or distinct. Okay? So don't go away thinking that real roots must be different, must be greater than 0. No. When the roots are equal, repeated, coincident, these are all meaning the same thing. The discriminant is equal to 0 and that is still real. Alright? Okay, question 41.
40?
Oh, sorry, 40. Chikian, how should we start this question? Simultaneous equation. Okay, I see two equations over here. Let's call this 1 and let's call this number 2. Solving them simultaneously, I get, I'll sub 1 into 2. Sub 1 into 2. Giving me 4x plus k square equals to mx. Okay, by the way, what kind of graph is this?
Curve.
What kind of curve is this?
Upward. I mean, parabola opening upwards.
How do you know it's opening upwards?
Because it's positive.
What is positive?
The x square.
Where got x square?
16 x square.
Where got 60?
When you
Yeah, forget already, right?
eh?
Opening to the
Right.
right. Parabola opening to the right. But this is not tested for our upcoming AMS test. Next. Now that we do this simultaneously, I know that I will end up with a quadratic equation. 16x squared plus 8kx plus k squared minus mx equals to 0. Okay, Chicken, what next? Hey, Chicken. I already helped you by changing it to become equal to 0 already. Factorize. Why you want to factorize? Change it into ax squared plus bx plus c, is it? Wait, hang on. Do you want me to change it to ax squared plus bx plus c equal to 0? Okay, so 16x squared plus 8k minus m x plus k squared equals to 0. Is this what you want? Now the whole class, are you able to do it until this step by yourself?
Yes.
What is the whole point of doing it this way?
Get the ax square plus bx square plus c.
X plus c equals to 0, right? This is what we want to write it as. For what? Find discriminant. Is it? Find discriminant. Okay, what is the discriminant now?
8k minus m square minus 4, 16 k square.
Okay, this is my discriminant. So what? Why do we want the discriminant? Why? To Make it equal to 0. You already made the equation equal to 0. So why do you want to find the discriminant? Okay, what do you want? Okay, let me evaluate the discriminant. Here we've got discriminant m squared minus 16km equals to 0. What should I do with it? Sorry. M squared minus 16km. Okay, what should I do with this? Factorize. Okay. So he says factorize, so we get m minus 16k. Yeah, like this. And then? How to find m? Why is this equal to 0? Now class, I think all of you agree that we should find the discriminant. But what do we do with the discriminant? So he help us simplify, help us factorize. Then what do we do with it? G and y equals to 0. Why is this equal to 0? What about tangent line? Okay. The line is tangent to the curve. Is tangent. So it cuts at one point. We don't even say cut, we say meets at one point, right? So it looks something like this. Okay? Something like this. How many solutions are there? So how many roots are there? One root, right? Or we can call it as two repeated real roots. Therefore, the discriminant is 0. This is why we say this is equal to 0. Okay? So therefore, m equals to 0 or m equals to 16k. Alright? At this point, then we can conclude that m is a multiple of k. Because m is simply 16 times k. Whatever k is going to be, you multiply by 16, you will get m. M is a multiple of k. Understand? Okay, so over here we write proven. Yes. We call it two repeated real roots. Any questions? Yes? What? No need. They only ask you to prove that m is a multiple of k. So here we have it. Oh, okay, wait. We should reject this one. Because you see, if you put m equals to 0 into this equation, yeah, y equals 0, right? Doesn't make sense already. Okay? Next. Question 41. Find the range of values of a such that 3x squared minus 9x plus a is always positive for all real values of x. Anybody don't quite understand the question? Very hard to visualize. Okay, good. So let's do it.
So you're gonna answer Eddie.
What's that?
Was it MPCC?
Yeah.
Oh, okay. Then never mind lah. Okay, class. We are now going to put in the equation. Y equals to 3x squared minus 9x. Y equals to 3x squared. What's after that? Minus 9x plus a. Okay, then here we have an add slider. So you see depending on the value of a, can you see that the graph changes? Understand? Do you understand how a changes the shape of the graph?
Yes.
Okay. Back to the question. It says that there happens to be a range of a such that the graph is always positive for all real values of x. Do I have the graph being positive for all real values of x at the moment?
No.
Because some parts are below the x-axis, right? If I move it to the left, if I make A smaller and smaller, am I getting closer to making the graph entirely above the x-axis?
No.
Why not? What actually is the effect of this A over here on the graph?
Pushes the graph down. Makes the
not the y-intercept. This is not y equals mx plus c. This is y equals to ax squared plus bx plus c.
makes the turning point lower.
Makes the turning point lower. Okay. What happens when a equals to 0? Okay, see over here, 0. So y equals to 3x squared minus 9x, correct? Right?
Yeah.
Now, if I let a be a negative number, for example, a is negative 1. For all the same values of x, what happens to the value of y now?
Negative 1.
No, it won't work.
Yeah, so you see, when x equals to 0, y equals to 0 here, right?
Yeah.
This is for this case. Now, for the same value of x that I substitute inside here, if I say now a equals to negative 1, then what happens to y?
Negative 1 to 1.
Negative 1, right? Because for the same value of x, this a, which in this case is negative 1, shifts the original value of y down by 1 unit. Understand?
Yeah.
What happens when a is negative 3?
Then y
Then when x equals to 0, y equals to 0 minus
negative 3.
3. Same for example this point. Currently, I do not know what this minimum point is, but it has a certain value of x, it has a certain value of y. If I change this a to negative 3, for the same value of x, or here I put in the value of x, then minus 3. So this point will now be shifted down by another 3 units. Understand? So when I shift the value of a to become negative, the graph goes lower and lower. It is actually the graph going lower and lower. So what happens when a is now shifted in the other direction? Then it goes higher and higher. It is called a translation. Do you learn this word before?
No.
Translation. It's just shifting it upwards.
Not
Shifting it
stretching,
downwards. No, not stretching. Stretching is like stretching a rubber band. Whereas translation is just simply shifting the rubber band up. So at some point in time, the whole graph will be at the x-axis, isn't it? So over here, about 6.7, we have the graph on the x-axis. But when it goes beyond that, the whole graph is now above the x-axis, correct? Okay, so yeah, this is what it looks like. Now what do we do in order to get the value of a greater than 6 point something out? Because that's going to be the answer.
Touches 0.
What do you mean touches 0? Where got discriminant? I don't even have an equation over here.
Isn't the...
Where got equation? Do you have an equation?
No, it's not equation.
You see, discriminant ax squared plus bx plus c equals to 0. Then I have discriminant equals to b squared minus 4ac. Okay? Only when I have ax squared plus bx plus c equals 0, then I have my discriminant. So at the moment, what should I be doing?
Make it an equation. Let 3x squared minus 9x plus a equals 0.
Why let it be equal to 0? Why?
You have to make it an equation.
So why not let it be equal to 1? So you see, cos B is suggesting that let 3x squared minus 9x plus a equal to 0. Because Mr. Wong says you must have an equation.
Yeah.
So why not let it be equal to 1? Then we have 3x squared minus 9x plus a minus 1 equals 0.
Can also...
When you put equal to 0, it will be simpler. Yes, it is simpler, but why? Will it be correct if I let it be equal to 0? Okay, hang on. So Cheng Zhuo is saying that this should be equal to 0. Why? Values of x is positive, no? Wait, let me talk first. No, they didn't say all the x is positive over here. Read carefully. What is always positive? There is no equation.
The solution.
This part is always positive, right? This is supposed to be quadratic, isn't it?
Yeah.
We know it looks like this. We just don't know where the x-axis is. Whether the x-axis is here, or here, or here, I don't know yet. So, how? Why must let it be equal to 0? Ernest,
Say whatever.
what is less than 0? Minus? Why? For it to be positive, it must be above the x-axis. Okay, then. Therefore, what? Then there is no real roots. Okay, I agree with you so far. Then what should I do? Okay, do you agree with his logic? When there's no real root, discriminant should be less than 0, right? I agree with you. But what's the discriminant? Oh, b squared minus 4ac? b squared minus 4ac, right? What is the b squared over here? So you're saying this is less than 0, is it? He's saying this is the discriminant. But he hasn't answered our question, right? Why must this be the equation? Why must this be equal to 0 for you to obtain this discriminant? Do you agree that when this one changes, if it is not 0, if it is, for example, 3, the discriminant will change? Yes, right? So why are you letting it be equal to 0? Okay, Darius has a point already. Finally, x over here, and this is the graph of y equals to 3x squared minus 9x plus 8, correct? Okay, so this is one possibility. I'll draw in a few more possibilities for you. Y equals to 3x squared minus 9x plus a. Y equals to 3x squared minus 9x plus a. Do you agree that these are the three possible cases, the red, blue, and green graphs for the parabola?
Yes.
Right? It's either crossing the x-axis at 2 points, or it is touching at 1 point, or it absolutely does not touch, right?
Yeah.
Okay. So when we say there are no solution, it is always positive. Yeah, there is no solution for. There is no solution for the equation, but what is that equation? What is that equation now? You tell me why, then wrong already.
3x squared minus 9x.
The equation is 3x squared minus 9x plus a equals to 0. Why is that so? Look, what is the equation of this x-axis? Y equals 0. Y equals to 0. Let me put it in black.
Oh, y must be 0.
Y equals to 0 over here, right? Now, red graph and x-axis. Let's put it in black color over here. Red graph and black graph. Any intersection or not? No intersection. So if I do simultaneous equation, will I have answer?
No.
Listen carefully again. Red graph and black graph.
Don't touch.
If I do simultaneous equation, will I have solution?
No.
No solution, right? What do I mean when I do them simultaneously?
If the graph touches, check if got any solution where they touch.
When I'm talking about simultaneous equation, I'm looking for points of intersection. So I should be using this as equation number 1, this as equation number 2, right? Solve them simultaneously. What will it look like when you solve 1 and 2 together? 3x squared minus 9x plus a equals to 0. This is the reason y, we can say therefore discriminant equals to everything over here lah. Understand?
No, not so. I rewatch.
Give you, yeah, go and rewatch. So the rest you should be able to do it by yourself already. You mean the answer? You check the answer key by yourself. Okay. Class. Since we were doing question 41 just now, I want to go on to 44 first. Read the question. Read the question.
The least positive integral, the smallest, simultaneous equation.
Okay, now,
Never like any other way.
Wilden, tell us how to start. What? Simultaneous equations. Okay, so over here I've got equation number 1, equation number 2. Doing simultaneous equation, do you want to start 1 into 2 or 2 into 1?
1 into 2.
Okay, 1 into 2. So 4 times of y becomes px minus 2 minus 3 equals to x squared. Okay, so why do you want to do simultaneous equation over here? From here you want to rewrite into ax squared plus bx plus c. Okay, let's do that. So 4px, this is minus 5 minus 20 equals to x squared. X squared minus 4px plus 20 equals to 0. Okay, you got to form ax squared plus bx plus c equals 0 already. What do we do next? What was the whole point of doing simultaneous equation in the first place? Because you want to find discriminant, okay. So now I've got ax squared plus bx plus c. What is the discriminant given by? Is this what you said? Negative 4 square. Okay. So b square then minus okay. So you do, then you will get discriminant equals to okay. Equals to 1 x p square minus 5. Now what? Wait, sorry, hang on, this will give me 16p square minus 80. Okay, what do we do over here? Okay. Do you all agree with this statement? The discriminant now is greater than or equal to 0. Why?
Never say it. Huh?
Do you agree? Because now he found the discriminant and then he's telling me that it is supposed to be greater than or equal to 0.
Could be.
Anybody disagrees? Or who agrees? Who agrees with him?
Doesn't look.
Looks like more than half are unsure. So Wilden, can you explain why? Must it be greater than or equal to 0? What meets the curve? The line meets the curve, implying that, what does this imply?
Touches once, touches twice.
Okay, so he says that this is y equals to px minus 2 either tangent to curve or y equals to px minus 2 cuts the curve at 2 points, right? Okay, let's talk about cuts the curve at 2 points. When you have a line that cuts the curve at 2 points, what are you trying to do? What kind of equations are you trying to solve?
Simultaneous.
Simultaneous equation, right? A line cuts the curve at 2 points. You're trying to do simultaneous equation, which explains why that is what he did first. Do simultaneous equation. Then he tries to solve for answers of x. Okay? But in this case, we're not so interested in the actual values of x. We're interested in the number of solutions. So if it cuts twice, then there will be 2 solutions, right? So when you do the simultaneous equation, you will end up with a quadratic equation. By solving the quadratic equation, you will be able to get the values of x. But that's not what we're interested in. We're only interested in cutting at 2 points, means the discriminant must be greater than 0. Okay, this is the first part. The second option, when we say meet the curve, it can be tangent to the curve as well. So this tells me that the curve and the line intersect at only 1 point, right? So we are still doing simultaneous equation. If we are still doing simultaneous equation, we are still going to end up with quadratic equation over here, which we can solve to give us either 1 solution, 2 solutions, or no solutions. In this case, discriminant will be greater than or equal to 0, since it meets. So from here on, how do we solve this? How do we solve 16p squared minus 80 greater than or equal to 0?
Factorize.
Divide by 16, okay. So p squared minus 5 greater than or equal to 0. What next?
Factorize.
Factorize? To become? How to factorize this one? P minus square root 5. P plus square root 5 greater than or equal to 0, yes?
Yeah.
Why do it so, make it so difficult? How about we do it this way? P squared greater than or equal to 5. Is this correct so far? It's correct, right? Then how to continue? Square root lah. P greater than or equal to square root 5. Or plus minus, okay. So correct or not?
Yeah.
Correct.
Must change the sign.
So based on this, based on the blue color one, we get P greater than or equal to root 5 or P greater than or equal to negative root 5. Yes? Correct? Okay, let's combine them. This is P, negative root 5 and root 5. Oh, it's supposed to be here and here. So what is our solution? P greater than or equal to root 5, right? Right?
Yeah.
Okay.
Negative root 5.
Sorry, this one should be a n.
So should it be negative root 5?
It's an n. So I'm looking for a region of intersection. Hang on, I'm not done yet. Those who are copying, very good, but you need to make adjustments. Now let's look at the way I taught you in black color. In black color, we have, whenever you have a quadratic inequality, you must factorize. I didn't teach you this way. Okay, I shouldn't have crossed it first. I didn't teach you this one in blue. Now in black color, you must factorize. And this is how we factorize it. Okay? From here on, what shall we do next?
P equals... cannot. No, graph.
Graph, okay, graph. So this is our p-axis. Parabola opening up or down? Cutting at which point?
Negative 5. Negative square root 5. Positive square root 5.
Okay. Which region am I interested in?
The behind. The third region.
The top ones over here and over here, right? So my value for p will be
Greater.
less than or equal to
Negative 5. Square root 5.
or
Positive square root. Bigger than square.
okay. Now compare the answers we have over here in red
One and
versus this one. Which one do you think is correct?
red.
The red one is correct. This is incorrect.
Oh, thank
You never ever square root both sides when you have this inequality sign.
That's why.
You can square root both sides when you have an equal sign. But when it is an inequality sign, don't do that. Never ever do that. You end up with lots of problems. Can? So for those of you who copy down the blue color one, very common mistake. Because you are so used to using equal sign. Then your teacher tell you, oh, what you do on this side, you must do on the other side. Right? In fact, that's why I always tell you. You must do the same to both sides. However, it is only applicable for equal signs. Just like you multiply by negative sign on both sides. Can be done, right?
Change the sign.
For equal, can be done. For inequality,
Change the sign.
you must change the sign. Okay? So this is our answer for 44. Oh, okay, then they want the smallest positive integer. So what will it be? 3 lah, because root 5 is 2 point something, right? So the smallest positive integer must be 3. Okay, that one you can do yourself. Okay, probably we'll end with this question, number 42. Okay, this graph over here. If I have a graph of y equals to negative 3x squared plus nx minus 5, the value of n will change my graph. Right? For n equals 0, n positive, n negative, I'll get different graphs. Okay? Do you want to see on Desmos?
Yes.
Okay, negative 3x squared then plus nx hang on n x then minus 5. Okay, hey, why
No graph.
add slider. Okay, so here we have the graph of y equals to negative 3x squared plus nx minus 5, and I have a slider over here. We see that as n changes, the graph changes, right?
Whoa.
Now the graph is no longer simply moving upwards, moving downwards, moving left, moving right, because my constant in my equation is negative 5. If I change the negative 5, I will be shifting the graph up or down. However, this time the unknown is in the coefficient of x. So the graph moves this way. There happens to be a range such that such that the graph is negative for all real values of x. What does the graph negative mean for all real values of x? Must be below the x-axis. Okay. So in this case, is the graph entirely below the x-axis?
Yes.
This part also, right?
Yes.
When n happens to be about negative 7.7, then it will no longer be entirely below. When n is more than about 7.7 again, it is no longer entirely below. So, in order to solve this question, what shall we do? Discriminant.
Let become 0 first.
Oh, so negative 3x squared plus nx minus 5 equal to 0, is it?
Yeah.
Why must it be equal to 0? Same question again, right? Why must it be equal to 0?
I never watched the video yet.
Because we are considering whether it cuts the x-axis or not. And the x-axis has an equation of y equals to 0. So all those are mental sum you must do. Don't need to write down one. My fear is that students just anyhow write down equal to 0.
It's not always equal.
Yeah, it's not always equal to 0. Because the question, like in number 44, will be a line and a curve. So you better not come and tell me that this is equal to 0. And then find the discriminant. You are supposed to solve simultaneously. Understand?
Yeah.
So in fact, this question is actually a subset of the next question. Okay, never mind. Once I let this be equal to 0, I've got ax squared plus bx plus c equals 0. What can you tell me about the discriminant?
N squared minus 4, negative 3, 5.
Okay, what can you tell me about the discriminant?
More than 8, less than 0.
Less than 0, because
Below x-axis.
it is negative. It doesn't touch the x-axis at all. There is no solution over here. So the discriminant must be less than 0.
Draw graph.
Then you go and solve your quadratic inequalities and solve it. Can? Okay, just give me 1 minute. When I have a graph, a quadratic graph, always positive. Do you understand what this means? A quadratic graph is always positive. Understand or not? What does the graph look like? Parabola opening what? Parabola opening upwards. Where's the x-axis? Is it possible for me to have a parabola opening downwards?
No.
Can I have a parabola opening downwards and yet it is always positive?
No.
Like that can?
No.
No, there's no such thing. Parabola will always open downwards, right? Okay, so this is, in this case, what is the discriminant?
Positive. More than 0. Less than 0.
Less than 0. Cause no solution.
Oh,
Compare this with quadratic graph, always negative. Parabola opening up or down? Where is the x-axis? Discriminant?
Less than 0.
Less than 0. Take note that these two are discriminant always less than 0, okay? I will be uploading a video for the rest.